Good afternoon, everyone. So, welcome to my YouTube channel, Maths Avatarm. So, hope you all are good and you are doing well in your life. So, today we are going to see some more question on uniform convergence of function, and we say it problem set second. Okay. So, let's start today's session now. So, first question is let f and x is equal to k if x is equal to k 2 to the power n from some k belongs to n. Be define. Okay. And it is 0 otherwise. Be define on a closed interval 0, 1. Then fn is point for option number 1 is fn is pointwise convergent. Second is fn is pointwise convergent. Sorry, first option is fn is not pointwise convergent. Second option is fn is pointwise convergent. C option is fn not uniformly convergent on 0, 1. And D, both options B and C are correct. Okay. So first of all, you see that what is so fn. So fn is 1 if x is k to the power n for some k belongs to n. Okay. 0 otherwise. Okay. So let's see whether pointwise limit exists or not. So if x is equal to k 2 to the power n, okay, okay, then this implies x is also this multiplying in numerator and denominator, we can write like that. Okay. Now this is, you can consider some k dash. Let's say k dash is equal to 2k. So it is of the form k dash upon 2 to the power n plus 1. Okay. It means when it is fn, when it is x is equal to k 2 to the power n form, I have n is equal to 1 by definition of this. And what about this f n plus 1? It will be again 1 because it has form of this form. Again, you can multiply by 2 n plus 2. Let's say k double dash. K double dash is 2k dash. Now I can write it k double dash upon 2 n plus 2. So what I will n plus x is also 1. It means that if x is equal to k 2 to the power n form, then f and x is 1 for all. Sorry, f is of this form. Okay. Then we have n greater than equal to 1. Okay. Taking higher n, it will give you 1. So where it will converge, because this is a sequence equal to 1, it will converge to fx is equal to 1. Okay. So it means, okay. Now what about if x is not of this form? Then what? By definition of fn, it will be 0. It is not of the form this form. If it is not form of this form, multiplying 2 or in numerator and denominator, still it will not be of that form. Okay, otherwise it will suppose, okay, suppose my x is not of this form. Okay. So it cannot be of any form. This implies x cannot be of k dash 2 n for all n greater than capital N. Okay. It will not be. Okay. Sorry, you directly write. It will be good. If X is for all n belongs to n and k belongs to n, then Fn X is equal to 0. Okay, for all n belongs to n, and there it will converge. It converts to 0. So what is this function? Pointwise limit. So what is pointwise limit? Pointwise limit is fx is equal to 1 if x is of this form for some k belongs to n and n belongs to n. 0 otherwise. Now see that such points could also belong to closed interval 0, 1. Otherwise we cannot consider. Now what about this? If I consider this set x belongs to closed interval 0, 1, so that x is of this form. Okay. For some k and n belongs to natural number, then this is set of periodic rational numbers in closed interval 0, 1. They are all the dyadic rational numbers in closed interval 0. Dyadic collection of all the dyadic rational number in closed interval is a dense subset in closed interval 0, 1. It means if you take any two values in between, you will always find such kind of number in between. Okay. On such, and we know that on dyadic numbers, we have functional value 1, otherwise 0. It means it is behaving like a Dirichlet function. It means it is it is behaving like a Dirichlet function. So f is not a Riemann integrable function, and it is a standard example. Once you have a 1 at dyadic rational number on closed interval 0, otherwise that function is not Riemann integrable. It is not f is not Riemann integrable. f is not Riemann integrable. Okay. Now you see that Fn, each Fn is defined like this. Fn is, it is 1 if x is of this form. Okay. And 0 otherwise. Now you see that, suppose if I have fixed n. If fixed n I have, so this point k upon 2n will be, I am taking k belongs to natural number. So what are the possibility that this belongs to closed interval 0 for k belongs to natural number? What are the possibility? I can take k is equal to 1, 2, up to 2 to the power n. If I will go larger and k is equal to 2 to the power n plus, it will not be element of this. It means at which how many points f and x can be discontinuous. Only finitely many points, up to 2 to the power n points it can be discontinuous. Okay, it means fn has 2 to the power n points of discontinuities. And we know that if a function have finite, so 2 to the power n is finite because n is fixed. So if a function has only finite numbers of points of discontinuity, that function is always Riemann integrable. It means fn is Riemann integrable. For all n belongs to n. But its pointwise limit is not Riemann integrable. It means fn cannot converge to f uniformly, because if a sequence of Riemann integrable function converges uniformly to some function on a closed interval, that uniform limit has to be Riemann integrable. We know that fn converges to f pointwise. F is not Riemann integrable, but fn is Riemann integrable for each n. it means Fn cannot converge to F uniformly. Okay, so let's see which option is correct. So first option is not correct. Is pointwise. This option is also correct. And Fn do not converge. This option is also correct. So finally, this option is correct because it concludes both B and C. Includes both B and C. So D option is correct. Okay. Now move to second question. Now what is Fnx? What is Fnx? Fnx is this function. So where it will converge? It will converge to sine square x function. Okay, this is my fx. So what is the pointwise limit of this function? So now Fnx minus fx. What is that? Sine square x plus 1 by n minus sine square x. Okay. But we can apply. We know that because we know that sine x is a Lipschitz function. If sine x is a Lipschitz function, we always have this condition. We know this condition. If it is x, it is y. Absolute value x minus 1 ka. X is x plus 1 by n, y is x. That is 1 by n. It means fn x minus fx is less than equal to 1 by n. But this tends to 0 as intending to, and do not depends on x. So it means fn tends to f uniformly. Okay, uniformly. Now what about integration function g and x? G and x is equal to 0 to x sine square x plus 1 by n dx. I can change it to cos function. 1 minus cos 2x plus 1 by n. Okay. Now take integration. So this is x and this is sine 1 by 2 sine 2x plus 1 by n. Okay, 0 to x. Okay, so 1 by 2. So when I will put x and when I will put it will be x minus 1 by 2 sine 2x plus 1 by n. And when I will put 0, it will be plus 1 by 2 sine 2x plus 1 by n. Okay. Sorry, 1 by n. It is sine 1 by n. So it is 1 upon 2n. Okay, now you see that 1 upon 2x and 1 upon 4 sine 2 upon n. Okay, this function. And it is minus 1 by 4. Okay, sine 2x plus 1 by n. Okay. So what is this? This is equal to 1 upon 2x, 1 upon 4 sine 2 upon n. And what is this? After, so this is 1 upon n sine 2x plus 1 to n. Now you see that this is my g and x. Now this function is uniformly convergent because, okay, this function is uniformly convergent. You can check. Okay, so what is, you can check directly. Okay, no problem, we will check it directly. Okay, we can check it directly. What is pointwise limit of g and x? What is pointwise limit, where it will converge? It will convert g and x. Pointwise limit is where it will converge. It will not affect anything. When n tending to, it will become 0 and it will become 1 by 4 sine 2x. Okay, so pointwise limit is x by 2 minus 1 by 4 sine 2x. So what is, it is gx. Okay, so what is gnx minus g? So what is gnx? What is gnx minus gx? So what is gnx? X by 2 plus 1 by 2 sine 2 upon n. Okay, minus 1 by 4 sine 2x plus 1 by n. Okay, this is x. This is x, xn. And what is this gx? Sine x. So this is cancel out. Okay, now I can write like that 1 by 2 sine 2 upon n. You can take 1 minus 4 common, sine 2x 2 by n sine 2x. Okay, now I can write like that 2 upon n 1 by 4 sine 2x plus 2 by n minus sine 2x. Now again sine, here sine x is a Lipschitz function. Again we can write like that sine 2 upon n 1 upon 4. This is bounded by 2x plus 2 by n minus 2x. It will be cancelled out. So it is 1 upon 2 sine 2 upon n plus 1 by 4 2 upon n. So g n x minus gx. Now you see that this is less than equal to, and it does not depends on n. So this tends to 0 as n tending to infinity, and do not depends on n. Sorry, x. It means gn tends to g uniformly. Okay. Okay. So fn tends to f uniformly and gn tends to g uniformly. Now see what, which option is correct. So fn converges to pointwise a function f, but does not converge uniformly to on this interval. Okay, so this is false because fn converges uniformly. Fn does not converge pointwise to anything. This is wrong. Fn does not converge uniformly. This is also not correct. So fn converges uniformly. Oh, sorry, gn converges uniformly. So D option is correct. Now what about this? Now fn and gn are two sequence. Both are bound sequence of bounded functions. Each fn is bounded and fn converges uniformly. Okay. Okay. So now see this question. So fn converges to f uniformly. So let epsilon is 1. Okay. This implies there exists capital N belongs to N such that Fn, okay, minus f x here, okay, less than 1 because epsilon is 1. for all n greater than equal to capital, and x belongs to closed interval AB. Okay. Okay. Now see that. So this implies I can write fn x fn x is equal to fn x is equal to. So I can take n. So this statement is also true for n. Take n is equal to capital N. We have f n x minus f x less than equal to 1 for all n greater than equal to n. Sorry, for all x belongs to 0, 1. X belongs to closed interval 0, 1. Okay, now fx, I can add and subtract fn x plus f and x. So this is fx minus fn x plus fn x. So this is bounded by 1. So I can write 1 here. Okay. Now each fn is bounded since fn is bounded imply करता है there exists m greater than 0 such that fn x is less than for all x belongs to closed interval G. So it means what? Fx is less than 1 plus m for all x belongs to. It means f is bounded. Okay. Fn converges to f uniformly and each fn is bounded, then f is bounded. Okay. Now what about other option? Now what about gn? G. Now you take gnx is equal to 1 upon, I am defining x 1 upon n if x belongs to open 1 close and 0 if x is equal to 0. Now you see that okay. 1 minute. Let me take other function. This function is not working properly. Okay. Okay. So this function is working because if I am taking x, if I am taking x, so gn 0 is 0 for all. So what is limits? G0 it will come to 0, and if x not equal to 0, then gnx is equal to 1 upon x plus 1 by n. This will tends to 1 upon x. Okay. So what is gx? Gx is 0 if x is 0 and 1 upon x if x belongs to open 0, 1 close. But in the neighborhood of 0, 1 upon x function is not bounded. It means G point-wise limit need not be bounded, but uniform limit of a bounded functions has to be bounded. Okay. So G need not be, here G is not bounded. G is not bounded. Point-wise limit is G is not bounded. Not bounded, but each Gn is bounded here. Each Gn is bounded. Gn is bounded. So which option is correct? Uniform limit of bounded function is bounded, but point-wise no, limit need not be. So f and g need not be bounded. First option is not correct. First option not correct. Okay. First option is not correct. Both are bounded. This is not correct. F need not be bounded, but F is always, sorry, G. It should be G. G is always bounded. This is not correct. F is always bounded, but G need not be bounded. This option is correct. Okay. So what about this question? Now you see that. Now see that summation first series is this. What is Fnx? Fnx e to the power minus nq. Nq. So because I am taking my from this interval, it will be always bounded by less than 1. So this is m. This is my mn. This is bounded by mn. Why Weierstrass m test? Weierstrass m test, and this series is summation 1 upon n cube. This series is convergent. Okay. So this option is correct. This series, first series is convergent. Okay. First series is convergent. What about second series? Sin x. What about second series summation 1 to infinity sin nx upon n to the power 5, I think it is. And what about this sin x? Its absolute value. Sin is bounded by 1. It is n pi. Again, such type of series, that series whose term is this convergent by Weierstrass m test. Okay. Weierstrass m test, it is convergent. So second option is also correct. Second option is also correct. What about third option? Summation n goes to 1 to infinity x to the power n upon n to the power n. Now you see that we are taking, so what is x to the power n of n to the power n? We can take like that, this. Okay. Okay. So it is pi to the power n. Okay. So what about this? This. This. Pi to the power n, n to the power n, limit n tending to infinity. Infinity upon infinity, it is L'Hospital Road. Okay. 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 So I think I made mistake. I should want to correct it. Okay. There is some mistake. There is some mistake here. I have written type it. There is a typo. There is a typo in this question. This is not 1 to the power n. Okay. This is minus 1 to the power n. This is minus. This is x upon pi to the power n. It is, so this series is nothing but there is typo. X upon pi to the power n upon n to the power n, it is. Okay. So this is x upon pi to the power n. So what is this is x upon pi to the power n upon n to the power n. So it is, when I put x is equal to pi, it will be less than n to the power n. Such type of series is convergent, absolutely convergent. Okay, so option number C is also correct. So this option is correct. It means all the options are correct. Finally, this is correct. Okay. Now, what about last question? Okay. So this function is given, and for each fiction, we have to check whether it is uniformly convergent or it is pointwise convergent. Okay. Now, see this. Suppose Fn is given this a naught plus a1x plus a2 x square upon factorial t plus an x to the power n upon factorial n. So what is if suppose m is greater than n, then what is fmx minus fnx? What is this? This is what is this? A n plus 1 x to the power n plus 1 upon x n plus 1 a n plus 2 x to the power n plus 2 upon factor n plus 2 plus a m x to the power m. But ANs are bounded. It is given in question that AMs are bounded. Okay. AMs are bounded. So let's say bound is supremum of AN is M. Okay. Because ANs are bounded. Okay. ANs are bounded. We are taking, so supremum is finite. So we have AN plus 1 upon x to the power n plus 1 upon factorial n plus 1 AN plus 2 x to the factorial n plus 2 upon factorial n plus 2 plus an x to the power m. This is m here, factorial m. Okay, so we can take supremum. So this is less than supremum of n belongs to n, an, and this is, I can take r here because I am taking closed interval r minus r to r. So r to the power n plus 1, n plus 1, r to the power n plus 2, n plus 2 up to r to the power m upon factorial m. Okay, this is m bounded by m, r to the power n plus 1, n plus 1, r to the power n plus 2, factorial n plus 2, r to the power m upon factorial n. Okay. Okay, so this tends to 0 as m and n tends to infinity. Okay, because this is exponential series, and exponential series are convergent. Sorry, exponential function, exponential sequence, this sequence for any r, e to the power x 1 plus r upon factorial 1 plus r square upon factorial 2 rn upon factorial n. Okay, so this sequence, so it means this sequence converts to e to the power n. It means this is a Cauchy sequence. So when mn tending to 0, this is fixed, this will tends to 0. It means fn minus fm x here tends to 0. Okay, independent of x as m and n tends to infinity. It means Fn is Cauchy sequence, is uniformly Cauchy. It means Fn converges. Fn converges uniformly. Because every uniformly Cauchy sequence is uniformly convergent. So which option is correct? Let's see. So Fn uniformly convergent on minus r to r. Yes, this is correct. We have checked. Not pointwise current band. Once Uniformly convergent, pointwise is also, this is not correct. Fn is not uniformly, this is not correct, we have checked. Fn is pointwise convergent, but not uniformly convergent. It is uniformly convergent. Okay. So option number D is also not correct. So we have done all the questions in this session. If you have any problem and issue or the issue related to this question, you can comment me on my YouTube channel. So thank you very much for today's session. Like, share, comment, and subscribe my YouTube channel. Thank you very much for today's session. Thank you very much.